Welcome to our deep dive into Azure DevOps Pipelines. Today, we'll explore its architecture, data flow, and essential components that streamline continuous integration and deployment. Azure DevOps Pipelines is a cloud service that automates the building, testing, and deployment of applications, enabling continuous integration and continuous deployment. This detailed architecture diagram highlighting the PR pipeline, CI pipeline, and CD pipeline stages. The architecture comprises three main pipelines: pull request pipeline, which triggered by a pull request to the repository. It performs initial quality checks like linting, building, and unit testing. Continuous integration pipeline, which activated upon merging code. It conducts comprehensive tests, including integration tests, and publishes build artifacts. Continuous deployment pipeline, which initiated by new build artifacts. It deploys the application to staging and upon validation to production environments. Let's understand the sequence from code commit to production deployment. First is PR pipeline. A pull request to Azure Repos Git triggers a PR pipeline. This pipeline runs fast quality checks. These checks should include building the code, which requires pulling dependencies from a dependency management system. The use of tools to analyze the code, such as static code analysis, linting, and security scanning. Tests. If any of the checks fail, the pipeline run ends and the developer will have to make the required changes. If all checks pass, the pipeline should require a PR review. If the PR review fails, the pipeline ends and the developer will have to make the required changes. If all the checks and PR reviews pass, the PR will successfully merge. Next is CI pipeline. A merge to Azure Repos Git triggers a CI pipeline. This pipeline runs the same checks as the PR pipeline with some important additions. The CI pipeline runs integration tests. Integration tests can be resource intensive, so running them in the CI pipeline balances development speed and bug detection. It's also important to note that passing tests in a PR does not always ensure they will succeed after merging, as changes in the main branch can introduce new issues, highlighting the need for post-merge testing. These factors make the CI pipeline a better place for integration tests than the PR pipeline. These integration tests shouldn't require the deployment of the solution, as the build artifacts haven't been created yet. If the integration tests require secrets, the pipeline gets those secrets from Azure Key Vault. If any of the checks fail, the pipeline ends and the developer will have to make the required changes. The result of a successful run of this pipeline is the creation and publishing of build artifacts. Then moving forward, next is CD pipeline trigger is the publishing of artifacts triggers the CD pipeline. Furthermore, CD release to staging is what? The CD pipeline downloads the build artifacts that are created in the CI pipeline and deploys the solution to a staging environment. The pipeline then runs acceptance tests against the staging environment to validate the deployment. If any acceptance test fails, the pipeline ends and the developer will have to make the required changes. If the tests succeed, a manual validation task can be implemented to require a person or group to validate the deployment and resume the pipeline. Next is CD release to production. If the manual intervention is resumed, or there's no manual intervention implemented, the pipeline releases the solution to production. The pipeline should run smoke tests in production to ensure the release is working as expected. If a manual intervention step results in a cancel, the release fails, or the smoke tests fail, the release is rolled back, the pipeline ends, and the developer will have to make the required changes. Last is monitoring. Azure Monitor collects observability data such as logs and metrics so that an operator can analyze health, performance, and usage data. Application Insights collects all application-specific monitoring data, such as traces. Azure Log Analytics is used to store all that data. Let's understand the key components of the data flow in detail. First is an Azure Repos Git repository serves as a code repository that provides version control and a platform for collaborative projects. Second is Azure Pipelines provides a way to build, test, package, and release application and infrastructure code. This example has three distinct pipelines with the following responsibilities. PR pipelines validate code before allowing a PR to merge through linting, building, and unit testing. CI pipelines run after code is merged. They perform the same validation as PR pipelines, but add integration testing and publish build artifacts if everything succeeds. CD pipelines deploy build artifacts, run acceptance tests, and release to production. Third is Azure Artifact Feeds allow you to manage and share software packages such as Maven, NPM, and NuGet. Artifact feeds allow you to manage the life cycle of your packages, including versioning, promoting, and retiring packages. This helps you to ensure that your team is using the latest and most secure versions of your packages. Fourth is Key Vault provides a way to manage secure data for your solution, including secrets, encryption keys, and certificates. In this architecture, it's used to store application secrets. These secrets are accessed through the pipeline. Secrets can be accessed by Azure Pipelines with a Key Vault task, or by linking secrets from Key Vault. Fifth is Monitor is an observability resource that collects and stores metrics and logs, application telemetry, and platform metrics for the Azure services. Use this data to monitor the application, set up alerts, dashboards, and perform root cause analysis of failures. Sixth is Application Insights is a monitoring service that provides real-time insights into the performance and usage of your web applications. Seventh is Log Analytics Workspace provides a central location where you can store, query, and analyze data from multiple sources, including Azure resources, applications, and services. Understanding Azure DevOps Pipelines is crucial for efficient software delivery. Implementing these practices ensures rapid and reliable application updates. That's a wrap on Azure DevOps Pipelines. Now, you have a clear understanding of how architecture, data flow, and key components work together to power CI/CD. If you found this video helpful, don't forget to like, share, and subscribe for more DevOps insights.